Welcome to BakoMaths, and today's lesson we'll be looking at the equation of a circle, where we are going to focus on the proof of the standard and general forms. And if you have not subscribed to this channel, kindly spend a moment and subscribe, so that when a new video is being uploaded, you're going to be the very first person to be notified. Now let's get started. So this video has its objectives, and by the end of this video, you will be able to 1. Explain what a circle is. 2. You're also going to be able to derive the equation of a circle. 3. Identify the forms of the equation of a circle. 4. Practically explain the properties of the equation of a circle. And the last one is to solve examples on the equation of a circle. Now, having known this, let's set the ball rolling. So with our first objective, it says the meaning of a circle. So when we talk of a circle, then we are talking about a set of points on a plane, equidistant from a fixed point. The fixed point is called center, represented by C, and the equal distance, that is the equidistant, is called the radius R. So practically, we are talking about a set of points, just like you can see here. So these are a set of points, but these set of points, they are at equal distance from a fixed point. So this fixed point is what we call the center. Now this center is at equal distance from where it is to any point we see. So the point from here to the center is of equal distance to any point on the circumference. So that's what we see. Now here is what we call the radius, and here is what we call the radius. Now when we join this point, we can see that it forms a nice circle. So practically, that's the meaning of a circle. Now from the center to any point on the circle is what we call radius. So the center to this point is what we call radius, represented by R. So that's the basic meaning of circle. Now, having known this, let's move to the equation of a circle. Good. So the equation of a circle has two forms. Generally, the equation of a circle has two forms, and they are: one, that is the standard form, and the next one is what we have as the general form. Now, this is what we have to note. When the standard form is expanded, it becomes the general form. So it simply means that if we are able to get the standard form, we can further expand it, and that will lead us to the general form. So you have the standard form, then by expansion, we can easily get the general form. So having known the various forms of the equation of a circle, now let's move to the proof of the standard form of an equation of a circle. Now we are the standard form of the equation of a circle. Now this is our Cartesian plane, and we can see that there is a circle drawn in it. Now these are the practical steps that are going to follow in order to get the proof of the standard form of the equation of a circle. Now let's be attentive here. Now, like we define circle, we said they are a set of points in a plane equidistant from a fixed point. So the fixed point here is the center. Now let's indicate our center in this circle. Now the center is made up of coordinates. So let's represent the coordinates by A, B. They are the coordinates of the center. Now from the center to any point of the circle, so let's indicate that point on the circle P with the coordinates X, Y. So making it nicely. So the point P with the coordinates X, Y. Now the distance from the center to any point, that's the point indicated P, on the circle is what we call the radius. So we have here as the radius. Now, joining this, then we can see that we are going to form a right-angled triangle. So knowing well that this is our 90 degrees angle. Now we have here to be C, we have here to be P. So we can also represent here by M nicely. Now, if at this point, if from the center is C and it has the coordinates AB, and this side is the x-axis. Then the distance between the center and the x-axis is what we have here as x minus e. Now, if this side is the y-axis, then the distance from the y-axis, or the distance between the y-axis and the center, is what we have here as y minus b. So we have this. Now we can see that we can equally apply Pythagoras theorem. Now let's write here, by applying Pythagoras theorem, applying the Pythagoras theorem, then we can see that the side PC is the hypotenuse. So you have here as PC squared is equal to, now the side CM, so you have CM squared plus the side PM. Now we have P as PM squared. Now what is PC? PC is what we know as R. So we have here as R squared is equal to, CM is what we know as X minus E. So you have here as X minus A squared plus PM is what we know as Y minus B squared. So this is what we have. Now, an equation of this form is what we call the standard form of the equation of a circle. So basically, we can see that hence, so that is hence. Now let's write this well. So hence, the standard form of the equation of a circle. Equation of a circle. So this is what we have as the standard form of the equation of a circle. Knowing well that the coordinates AB is the center and R is the radius, and then XY are points on the circle. So now we said from the beginning that the expanded form of the standard form gives us the general form. So having known this, let's move to the general form of the equation of a circle. So now we are looking at the general form of the equation of a circle. Remember that we said when we expand the standard form, then definitely we are going to get the general form. So now let's put from the standard form, good. We said that R squared is equal to, that is X minus E all squared plus that is Y minus B all squared. So this is what we had at the standard form. So we are going to expand. Now we have R squared to be equal to X squared minus 2AX plus A squared. That's the expansion of X minus A all squared. And we come to the expansion of Y minus B all squared. Then we have Y squared minus 2YB. So that can be BY. That is the correct order. So that is minus 2BY. And we have here as B squared. Now we can rearrange them, and we have X squared plus Y squared. You can have here as minus 2AX and minus 2BY, and also have here as plus A squared plus B squared. Now we can also transpose R squared to the right hand side, equating everything to 0. Now that becomes X squared plus Y squared minus 2AX minus 2BY plus A squared plus B squared minus R squared is equal to 0. So now we have this. So we can, to continue, we can equate the center, that is A, to a particular variable. But before we do, let's also try and then simplify it further. Now here we can factorize negative A out, leaving 2x in, then represented by a variable. So that becomes x squared plus y squared. Here we have minus a multiplied by 2x, and then we can also have minus b multiplied by 2y. We here have a squared plus b squared minus r squared is equal to 0. That is that. Now what we can do here is that we have been able to factorize the centers, that is a and b out. Now they are negative, so we can see let's negative a be equal to g, and then we can also represent negative b by f. Now this implies that we are going to have here as x squared plus y squared. So we are seeing negative a be equal to g, then it means we're going to have plus 2gx, and then we are saying negative b should be f, which implies we're going to have plus 2fy, and then we have a squared plus b squared minus r squared is equal to 0. Now in the same way, we can also equate the terms a squared plus b squared minus r squared by a common term. So that is, you can also say let's a squared plus b squared minus r squared should be equal to c. Now our equation now becomes this form. So here we have x squared plus y squared plus 2gx, and then we have plus 2fy plus c is equal to 0. Now an equation of this form is what we call the general form of the equation of a circle. So hence, now let's write here, hence the general form of the equation, hence the general form of the equation of a circle, of the equation of a circle. So that is it. So this is the general form of the equation of a circle. Now this general form has its center and radius. So you can get it from where we equated negative a is equal to g and negative b is equal to f. Now remember, from here we said that we should let negative a be equal to g. So by making a the subject, that's making a positive, then it will imply that our a, that is from negative a is equal to g, then to imply that our a is equal to negative g. Now a is the center, and the center is positive a, not negative a. So it implies that I have to make a positive. And also we also said that negative b should be equal to f. Now it implies that the center b is equal to negative f. So from here, the center, we know the center of a circle, that is a comma b, is now negative g comma negative f. Negative g comma negative f. Good. So this is when we are using the general form of the equation of a circle. So using the general form of the equation of a circle, its centers is negative g negative f. And then the radius, remember we also said that the radius, that is a squared plus b squared minus r squared, should be equal to c. So that is from that. So we can also quote from a squared plus b squared minus r squared is equal to c. Then we can practically make c the subject. So that is, we transposing c to the right hand side and then transposing the rest to the left hand side. That becomes a squared plus b squared minus c. By taking square root of both sides, then means that our r now is equal to the square root of a squared plus b squared minus c. So this becomes the radius. So it means that the general form of the equation of a circle, that is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0, has its center as negative g negative f, and then it has its radius as r to be equal to the square root of a squared plus b squared minus c. So that is that. So these are the main things that I have to note when using the general form of the equation of a circle. So that is the simple put of it. Now, having known this, let's move to the next one. Now, next is for us to look at the properties of the equation of a circle. That is specifically looking at the properties of the general form of the equation of a circle. Now, let's set the ball rolling on that. Properties of the equation of a circle. The equation of a circle, x squared plus y squared plus 2gx plus 2fy plus c is equal to 0, has peculiar properties as follows. Now, before we can term an equation of this form as an equation of a circle, then it must follow these three properties. The first one we see says that it is a second degree equation, which simply means that the highest degree of the equation is 2. Now, looking at x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Its highest degree here is 2. That is, the degree of x is 2, the degree of y is 2. When we come to this side, the degree of x and y, they are 1. So that makes it a property of the equation of a circle, emphasizing the fact that the second degree, it is a second degree equation. So that is one. The second one we are talking about, it says that the coefficient of x squared and y squared is equal. Now, let's look at this. The coefficient of x squared here is 1. And then the coefficient of y squared here is 1. And that makes it an equation of a circle. So for us to term an equation as the equation of a circle, following the three properties, the second one is saying that they must have the same coefficient. So if the coefficient of x squared here is 6 and the coefficient of y squared here is 5, then this is not an equation of a circle. For it to be an equation of a circle, then they must all have the coefficient as what? As 6, 6. So it must be 6x squared and 6y squared. That makes it an equation of a circle. Now, the third one, we are looking at the fact that there is no term in xy. When you look at the equation of a circle, there's no term like xy here. It is just 2gx and 2fy. So practically, if we have an equation of this form, x squared plus y squared plus 2x plus 4y minus 8 is equal to 0, then we can say that this is an equation of a circle. Now let's follow the three properties and see. The first one says that it is a second degree equation. Yes, we can see that the highest degree here is 2, and that works. The coefficient of x squared and y squared is equal, and we can see that the coefficient of x squared is 1, and then the coefficient of y squared is 1, and that makes it equal, and then it works too. Now, there is no term in xy. What you can see here is just 2x and 4y, and that is what we want. So that is the perfect way. There is no term like 2xy or a term like 4xy. If something like that happens in the equation of a circle, then it is not an equation of a circle. Now, practically, assuming we have x squared plus y squared plus 2xy plus 4xy minus 8 is equal to 0, then this is not an equation of circle. The first one, that is, it has a second degree equation, or it's a second degree equation, works. And the second one, the coefficient of x squared and y squared is equal. Yes, they have coefficient of 1 and 1. That is correct. But there is a term in xy, that is a term xy here and the term xy here, making it not to be qualified as an equation of a circle. So before we can classify an equation as an equation of a circle, these three criteria must be met, following that order. Now, having known this, let's look at some exercises under the equation of a circle, and let's put this into practice. Now, the exercise here. Identify whether or not the following are equations of a circle. Identify whether or not the following are equations of a circle. to test our understanding, I would like for you to pause the video and go through. Later you unpause it and listen to the answers. Now the first one, we have 2x squared plus y squared plus 3x minus 4y plus 4 is equal to 0. Now the first one, that is the coefficient of x squared here is 2 and the coefficient of y squared here is 1, and they are not the same. So because of that, this is not an equation of a circle. So you can say not an equation. So let's put it short that way. So not an equation of a circle. Because the coefficients are not the same, it does not qualify for it to be called an equation of a circle. Now the second one, x squared plus y squared plus 7xy plus 5y minus 6 is equal to 0. When you look at this, there's a second degree equation, alright? They all have the same coefficient of 1, but there is a term in xy. But the property said that there is no term in xy. So because of this, it qualifies this not to be an equation of a circle. So we can say not an equation of a circle. Not an equation of a circle. Now let's move to the third one. We have x squared minus y squared plus 20x minus 3y plus 4 is equal to 0. Now look at the equation of a circle correctly. We said it is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So it implies that the sign in between x squared and y squared is never negative. It is always positive. But for 2gx and then 2fy and then that of c, their sign changes. It can be positive or negative. But in between x squared and y squared, it is always positive. And that makes it an equation of a circle. By comparing with this one, we can see that the sign in between x squared and y squared here is negative. And because of this, it does not qualify it to be an equation of a circle. So hence, we can see that it is not an equation of a circle. Not an equation of circle. So that is that. So practically, you can see that all these three equations are not equation of a circle. So having known this, we are going to end today's video here, and we see you in our next lesson. And so thanks for watching. Kindly like, comment, subscribe, and share. This is BakoMaths, thinking beyond infinity.